Good morning, friends. Today I will do simultaneous linear equations in two variables. See, any two variable if taken in the form of the equations, then a linear pair of the two equations they form the simultaneous linear equations. Suppose x plus y plus c is equal to 0, that is a equation where x and y are the variables and c is a constant term. This equation can be written in the form of x plus y is equal to c also. Now, two equations are there, a1x plus b1y plus c1 is equal to 0, and second is a2x plus b2y plus c2 is equal to 0. Here a1, b1 are the coefficient of x and y, and c1 is the constant term. Now first I will explain what is the ratio between the coefficients of the two variables. Say a1 coefficient of the x, first equation, a2 is the coefficient of x in second equation, then a1 upon a2, and b1 coefficient of the y in first equation and b2 coefficient of the y in second equation, that is b1 upon b2, and then c1 upon c2. See, when we plot the graph of the two variable equations x and y, first condition that if a1 upon a2 ratio is not equal to b1 upon b2. In first case, ratio of a1 upon a2 is not equal to b1 upon b2, then if you plot the graph, you will get the two lines they intersecting at a point. That will be the solution of x and y. Here see the pick. Here one equation, second equation they cut at a point x. Then x, y are the two solutions of the two variables. This type of the equation is known as the consistent, and it will have a real and the unique solutions. So the first point is that in a given equation, if ratio of a1 upon a2 is not equal to b1 upon b2, then this equation will be a consistent equation and it have the real and the unique solutions. Now if second case a1 upon a2 is equal to b1 upon b2, but it is not equal to c1 upon c2, it means a1 upon a2 is not equal to c1 upon c2 and b1 upon b2 is not equal to c1 upon c2. In this case, if we draw the graph, we will get the two straight lines, that is parallel lines, they never intersect each other. This type of the equation is known as the inconsistent, and it will have no solution, or when the two lines they are parallel to each other, they will never intersect. That is, such type of the equation they have no solutions at all. It is known as the inconsistent. So the point is that, again listen, a1 upon a2 is equal to b1 upon b2, that is the ratio of the coefficient of x is equal to the ratio of the coefficients of the y, but it is not equal to the ratio of the c1 upon c2. In this case, it will have no solution and it is known as the inconsistent. Now in third case, when the ratio of a1 upon a2 is equal to b1 upon b2 and c1 upon c2, all the ratios of a1 a2, b1 b2 and c1 c2 are equal, then it is known as the coincident equations and it will have the many solutions. Here you will find that both the lines they coincident on the graph. A straight line is there, both the lines overlap each other. So these are the three conditions in the simultaneous linear equation in two variables, whereby the ratio of the coefficient of the x and y, we can say that whether the equation is consistent or inconsistent or the coincident. Now this is a general fundamental pattern linear equations giving the ratio of the coefficients of x and y. Now in my next video I will explain how you will find the value of x and y. There are 2-3 methods. One is elimination method, other is substitution method, and third is cross multiplication method. So today I think it will be clear to you some fundamentals for the simultaneous linear equation. Please like and share it. Thanks very much.